Okay, so we're going to go ahead and we're going to start chapter 5. So with chapter 5, we're doing something called antiderivative or indefinite integrals. Antiderivative, opposite of derivative, or integrals. Kind of the two names, they're the same thing. Okay, so before we do anything, let's just remind ourselves how to take a derivative. Okay, so I'm going to give you this one, and I'm only going to give you a minute. If I gave you x to the 4, I want you to take the derivative. Okay, just take the derivative. Don't say it out loud. Just give it a try. Take the derivative. Okay, so without even thinking, you probably took the derivative and you got 4x to the 3rd without even thinking, right? But let's break down what you actually did. What you actually did was you moved the 4 to the front and you multiplied by 4. So you multiplied first. And then how did the 4 become a 3? You subtracted 1. Are we okay with that? And we do it all the time. We get really comfortable with it, and we don't even think twice about it anymore. We just take derivatives. What we're going to do today is antiderivative, or called integral. We're going to work backwards. We want to start with the derivative and go back to the original. Now, the y we'll answer soon. We're just going to do the how first, and then we'll do the y later. Now, we know that this prime symbol means we took the derivative. What symbol will I use to take the antiderivative to take the integral? It's this really elongated S sort of looking thing. That's the integral symbol. That's the integral symbol. That means when you see that symbol, you're doing the antiderivative. You're doing the opposite of derivative. So we're going to start with 4x to the 3rd. And we know we should end up with the original x to the 4. But let's pretend we didn't. Let's pretend we didn't. Now, the only thing that's a little different or weird about integrals is after the integral symbol, it's what you're taking the integral of. Then you're going to see a dx down there. Now, I know that looks weird, but that dx is telling you take the integral with respect to x. That's what that means, with respect to x. And you're like, of course it's x. It's always x. Well, in the future, if you continue with calculus, it could be x, it could be y, it could be z. You could be dealing with multivariables. It gets harder, okay? But for us, it's going to be x, and that's just a reminder. But it's kind of like a preview of later on, okay? Now, the antiderivative is the opposite, right? So what's the opposite of multiply? Divide. And what's the opposite of subtract 1? Add 1. And we're even going to do the opposite order. We multiplied first. We're going to divide second. We subtracted 1 second. We're going to add 1 first. So basically, it's doing the opposite. The opposite of multiplying is dividing. The opposite of subtracting 1 is adding 1. And that hopefully kind of makes sense. It's the the opposite. So the number in front stays in front. The number in front stays in front. So the 4 stays in front. And what we're going to do is we're going to add 1. So what's 3 plus 1? 4. The new number formed is 4. And then we're going to divide by 4. So all you're learning today, except for a few special cases, is add 1 and divide by it. Add 1 and divide by it. Add 1 and divide by it. That's all you're going to learn today. And what happens when you take 4 divided by 4? You get 1x to the 4. Did we get the original back? Yep. Now, there's going to be some little extra that I'm going to explain over time. But when you take an integral, it always ends with a plus c. When you take an integral, it always ends with a plus c. That's your constant of integration. Bottom line is it represents the number that could be there. And you're like, what are you talking about? We'll get that. We'll get there soon. We'll get there soon. Okay. But as of right now, Only thing you need to understand is we're doing antiderivative, which is called integral, and it's the opposite of derivative. The opposite of divide and subtract one is add one and, multiply and subtract one. The opposite is add one and divide. Not too bad there. So let's do it again. Let's do it again. Let's do it again. So to practice that, the whole process again, but a little bit longer. So let's say the original was 3x squared minus 4x plus 7. I would like you to take the derivative of that. Should only take a minute. Take the derivative. Okay, so the original is 3x squared minus 4x plus 7. If you take the derivative, you should get 6x minus 4. And what's the derivative of 7? 0. Derivative of any number is 0. Good so far? Now, if I take the integral of 6x minus 4 with respect to x, what should I end up with? The original. We'll see. So what's going to happen is what happens to the number in front? The 6 stays in front. This is a 1. The only thing you're learning today is add 1, divide by it. So what's 1 plus 1? 2. And then what do I do to the 2? Divide by it. And let's just do that real quick. 6 divided by 2 is what? 3x squared. Did we get the first one back? Perfect. Okay. Now, this is where it gets a little weird, and we're going to go ahead and take our time. There's no variable here, correct? So let's call that x to the 0. There's no variable. X to the 0 means there's no variable. There's no x's. But if the number in front stays in front, minus 4, if you add 1, what's 0 plus 1? 1, and then divide by it, add 1, divide by it, add 1, divide by it, you're left with minus 4x. I got the second part. Here's where the problem is. What's the derivative of 7? What's the derivative of 10? 0. What's the derivative of 100? 0. What's the derivative of negative a million? 0. They're all zeros. So how am I supposed to know what that number is if the derivative of any number is 0? I don't. That's why we always put a plus c. That plus c represents the number that could have been there, because the derivative of any number is 0. And we won't know unless we had some more information or knew the original or had some given information that I can solve for it. So that's why we have the plus c. That's why we have the plus c. Now we're going to practice one. I'm just going to give you the integral of 4x squared minus 5x plus 3 dx. Okay, so I'm not giving you the original, take the derivative, take it backwards. We're starting with the integral. We're starting with the integral. We're starting with the integral. And I'm just going to give you a minute. Just try it. Right or wrong, just try it. Take the integral. Be careful. Be careful. Give it a try. Give it a try. Take the integral. So now we're starting with take the integral of 4x squared minus 5x plus 3 dx. So just to remind you a couple things, this integral symbol means take the derivative, take the antiderivative, antiderivative, antiderivative. And dx just means with respect to x. When you take the integral with respect to x, both of those just drop out. Both of those drop out. Okay? So what we're learning is the number in front stays in front, add 1, 2 plus 1 is 3, and divide by it. Now stop there. If you got that, you got today's lesson. I'm going to add fractions and decimals, and you're going to think it's so much harder, but that's it. Right there, if you can do that, that's today's lesson. The number in front stays in front, add 1, divide by it. Add 1, divide by it. That's all we're learning. So that becomes 4/3 x to the third. Okay, the next one, minus 5, number in front stays in front. This is x to the 1. So we're going to add 1, that's 2, and divide by it. So that becomes minus 5/2 x squared. Then the last one doesn't have a variable. So to help you understand, then we'll develop a shortcut. There's no variable. So this is like x to the 0. There's no variable there. So the 3 stays in front, add 1, that's 1/1, and you get 3x. So if you're looking for a shortcut, what's the antiderivative integral of 3? 3x. What's the antiderivative or integral of 5? 5x. Of 10? 10x. Of 100? 100x. And why? Well, I'm going to answer that question in just a minute. And then every time you take an integral, what do you need to put at the end? Plus c. That plus c is to represent the number that could have been there. Are we okay? Now, can we check this? Can we check this? And the answer is yes. If you take the integral to find the original, how can I check it to make sure that's correct? Take the derivative. Now, I'm not going to check all of them, but you can check all of these. Be careful, those that are bad with fractions. When you take the derivative of this, 3 times 4/3 is 12/3, which is what? 4x squared minus 2 times 5/2 is 5x. What's the derivative of 3x? 3. And the derivative of any number is 0. Did we get 4x squared? 4x squared. Did we get 5x? We got 5x. Did we get 3? Did we get 3? That is how you check it. So if you want to check it, you take the derivative. If you want to check it, you take the derivative. Why? You just did the antiderivative. So to get it back is the derivative. To get it back is the derivative. Now, there are a few special cases that I need to go over, but let's do a couple more vocabulary. We take care of that. First of all, this is called taking the indefinite integral. Now, you're saying, why isn't it just integral? Why is it indefinite integral? Because there's no number on the bottom, no number on top. That means it begins forever and it ends forever. It's indefinite. We will add numbers here later, and then it'll be called the definite integral. Definite beginning, definite ending. Right now, it just goes on forever. So understand that there's no numbers, so we call those indefinite integral. The symbol is called the integral symbol. What you're taking the integral of is called the integrand, and that dx is the anti-differentiation. It's to say with respect to x. And the c is called the constant of integration. It's the number that could have been there. Then, as we're going through this, some examples, doesn't matter what letter you use. There are a couple special cases. And the answer is there are 2 special cases. 2 special cases at this point. Okay? One of them you're really going to like, and the other one I'm just going to have to explain a little bit. What is the integral of e to the x? That's the first special case. The integral of e to the x, is e to the x. Don't forget your plus c. So that one's pretty easy. And if you're wondering why, the derivative of e to the x is e to the x. So the integral of e to the x is e to the x. So that one's pretty straightforward. The second one, I need to explain a little bit. The second one, special case, can be written as 1 over x. Or if I rewrite it like we normally do, this is x to the 1. If I rewrite it, it's what? X to the -1. So either way, they are the same thing. You could see it as 1 over x, or you can see it as x to the negative 1. You tell me, why is that a special case? Go through the process. Why is that a special case? Yep. Perfect. If you add 1, you get 0, and that's actually not the problem. It's the second part. What are you going to do to that 0? Divide by 0. Can you divide by 0? No. So that's a special case. So what you're going to learn is the integral of x to the negative 1 is ln absolute value of x plus c. Now again, if you're wondering why, the answer to that is, you may or may not remember, but if you had ln of x, the derivative of ln of x was 1 over x. We're just going backwards. And then the absolute value part just ensures that it ends up being positive. Okay? But if you want to keep it simple, the two special cases you need to be aware of are e to the x, the integral of e to the x is e to the x, and if you have 1 over x or x to the negative 1, that's ln absolute value of x. That's it. Any other negative is fine. Decimals, fractions, negatives, everything else is fine. The only one you need to worry about is negative 1. And the reason why you need to worry about it is it gives you 0 and you can't divide by 0. Any other negative is fine. Like if this was x to the negative 3, add 1, what do you get? Negative 2, divide by negative 2, no problem. It's only negative 1. So having said that, having learned all this, here's an example for you. And you're going to think it's so much harder. And I'm going to say it's the same old. Okay? So I want you to do this one. 3x to the 2/3 fraction minus 4x to the 1.3 decimal minus 10 square root of x square root plus 12 dx. Okay? Take the integral of that. I am going to give you a little bit of advice. I would rewrite that square root first and then go through the same parts. All you're learning today is add 1, divide by it, add 1, divide by it, and the meaning behind it. So just like when we did derivatives, if it helps to rewrite it first, I totally would. So I would rewrite this integral 3x to the 2/3 minus 4x to the 1.3. And instead of square root of x, I'm going to put 10 what? X to the 1/2, right? Plus 12 dx. Now remember, the integral and the dx go together. Once you take the integral, they both drop off. So it's always a good idea to rewrite it first. Then I'm not going to use the calculator, but I want you to really start thinking about it. I'll use it at the end. But number in front stays in front. And all we're going to do is add 1. If you need the calculator, for example, 2/3 plus 1, parenthesis, 2/3, close parenthesis, plus 1, enter, you get 1.66666. Math, number 1 for fraction, you get 5/3, right? So there's no excuse, especially with a calculator. There's no excuse. So if you add 1, you get 5/3. And then what do you do to that new number? Divide by it. So all we're learning is add 1 and divide by it. Add 1 and divide by it. Okay? You're like, oh, fraction. It's the same stuff. You got to get over the fraction stuff. Okay? Then the minus 4 stays in front. Add 1. You get 2.3 divided by 2.3. The number in front stays in front. A half plus 1, you can put 3 over 2, or you can put 1.5. It doesn't matter. It's the same thing. I'll put 1.5. But if you put 3 over 2, fantastic. They're the same thing. And then if you want to do that shortcut, what's the integral of 12? 12x, right? We talked about it's x to the 0, add 1, 1 over 1. You get that. And don't forget at the end to put what? Plus c. Now, yes, at this point, you are correct. But 3 divided by 5/3, we can clean that up. So if we go to the calculator, 3 divided by, parenthesis, 5/3 you get this number. You can use 1.8 or math number 1 to fraction. You get 9/5. Remember skip, flip, multiply, all that. You get 9/5. So this would be 9/5 or 1.8 x to the 5/3 minus 4 divided by 2.3. 4 divided by 2.3 gives you 1.739. But if I go to math fraction, I can say 40 over 23. Either one's fine. Either one's fine. 40 over 23, x to the 2.3 minus 10 divided by 1.5. 10 divided by 1.5. That gives you 6.66666 for math fraction 20 over 3. X to the 1.5 plus 12x plus c. That would be your final simplified answer. Final simplified answer. You get the idea. Rewrite it if needed. Take the integral. If I took the derivative, I can check any one of these. Okay? So here's another one. Here's another one I want you to try. And just like last time, it would help you to rewrite it. But I'm going to start easier and then get a little harder, and you'll figure out, okay, I'm having problems with blank, blank, blank. So here's your example. Let me write it down first, and I'll read it. Okay, so this is take the integral of 5x to the 3rd minus 4x squared minus 2x to the 1/4 minus 7e to the x plus 2 over x minus 4 over x squared plus 5 dx.
Recording in progress.
Okay, so what I would do is first rewrite it. And again, the first one's ready to go. 5x to the 3rd. The second one's fine. 4x squared. The third one's fine. 2x to the 1/4. Fourth one's fine. 7 e to the x. But the next two, I would probably rewrite. This would be plus 2x to the -1 minus 4x to the -2 plus 5 dx. So again, just like with derivatives, if it helps to rewrite it first, then you're on your way. And as we go left to right, see if there's any issues. So the 5 stays in front, add 1, 4, divide by it. The 4 stays in front, add 1, divide by it, x to the 3rd over 3. The -2 stays in front, add 1. Now, if you're struggling with that, that would be 5/4 over 5/4, right? 1.25 is fine, however you want to do it. Then the 7 stays in front. There's your first special case. What's the integral of e to the x? E to the x. Then the 2 stays in front. What's the integral of x to the -1? ln absolute value of x. Now, why is that a special case? If you added 1, you'd get 0. Then dividing by 0 causes an issue. That those two right here, e to the x and x to the -1, those are special cases. Now, the -4 stays in front. Is -2 a special case? No, -2 is fine. Just be careful. If you add 1, you get -1 divided by -1. No problem at all. The only special case is -1, not -2, not -3, not negatives, just -1 because you get 0 and you can't divide by 0. And then what's the integral of 5? 5x. And after every integral, don't forget the plus c. Without the plus c, technically it is wrong. You will lose points. Okay? Then you did the hard part. You did the integral, but unfortunately, where a lot of people struggle is simplifying. That should not be the hard part. That should be the cleanup part, right? This ends up being 5 over 4, x to the 4, minus 4/3, x to the 3rd, minus. Now, if you did 2 divided by 5/4 in the calculator, you would get 8 over 5. Practice, practice. X to the 5/4 minus 7 e to the x plus 2 ln absolute value of x. -4 divided by -1 is +4. I would make the -1 positive by moving it to the bottom. plus 5x plus c. To me, that would be a final simplified answer. Final simplified answer. Now, I could sit here and just do a ton of examples, but we would just be doing a ton of examples. So I'm going to point a few out, and then I'll give you one more, and then we'll work on some word problems. So for example, for A, B, and C, this would be great practice. I'm not going to do it for you, but I will tell you where people make mistakes. So for example, if I was doing the first one, what should we do to that? We should rewrite it. That would be 5x to the what? -4. Now, again, I'm not going to do it, but that would be a good one to practice. Same thing with this one. If you had the integral of 4 cube root of x squared dx, you don't want to leave it like that, but you need to know how to rewrite it. So if I rewrote it, this would be 4x to the what? 2/3. And again, you're not able to take the integral of something if you can't rewrite it. So some people get stuck with the first part, and that's what slows them down. Now, for the next one, just to kind of show you, if you had the integral of x to the 4 minus 2 over x squared, you may say, hey, we haven't learned quotient rule or anything for integral, and there's not any of those rules, but there is some algebra that you could do. So what's being divided by x, first or second? Both. So this would be x to the 4 over x minus 2 over x. And then that could be rewritten as x to the 3rd minus 2x to the -1. So again, sometimes the rewrite takes a little bit of work, but it's all algebra, it's all algebra, it's all algebra. So that's just kind of some reminders and some practice. Now, here's the one for you. I want you to take the integral, be careful, of 2 cube root of x minus 6 square root of x dx. So again, rewrite it first, then take the integral, but the issue may be the rewriting, not the integral. So what I would do is rewrite this, and this one's going to take a couple steps, because this would be 2 over x to the what? 1/3. I'll move it up in a little bit. Minus 6. Square root of x is x to the 1/2. But then I want that 1/3 to go up. So that would be the integral of 2x to the -1/3 minus 6x to the 1/2 dx. So again, if you simplified it wrong or rewrote it wrong, everything else is wrong. So let's make sure we got that correct. Then it's fractions. It's okay. The 2 stays in front. Use the calculator if you need to. But what's -1/3 plus 1? 2/3 divided by 2/3. The 6 stays in front. 1/2 plus 1. I'll do 3 over 2 this time. But you can put 1.5. Don't forget your plus c. Okay, so be careful, be careful. Then again, you can use the calculator. If you're not sure what 2 divided by 2/3 is, you can go to the calculator and do 2 divided by 2/3. And you get 0.33333, which is math fraction 1/3. I'm sorry? It's 2 what? Divided by. So 2 divided by, thank you, 2/3. Type it in correctly. Gives you 3. Okay, and again, some of us like, why do we got to simplify? Why do we got to simplify? 2 divided by 2/3, nobody knows what that is, right? 2 divided by 2/3, it's just 3, right? That's why we clean it up. I'd rather see 3 than someone tell me 2 divided by 2/3, right? And then 6 divided by 3 over 2, which gives you what, 4? 6 divided by, 3 over 2. 6 divided by 3 over 2 looks complicated. It's just 4. It's just 4, right? This is why we simplify simple numbers. And that would be your final answer. Okay, so we spent a lot of time on how to do it, but we haven't talked about at all why we do intervals, So that's why we're going to go to our word problems. So here it says, now read it carefully, if the marginal cost, what's marginal cost mean? It's the derivative of cost. So you're not given cost. You're given marginal cost. So marginal cost is 0.3x squared plus 2x. And you're told that the fixed costs of $3,000, then find the cost function to produce 30 units. Okay, so first of all, we got a problem. Are you given cost or marginal cost? Marginal cost, that's derivative. And what I want is cost. So how do I go from marginal cost back to cost? The integral. So there's your y. If you are given a marginal cost, which is a derivative, and you need to work backwards, take the integral. So just do step one, go from marginal cost to cost. So in this case, you're given marginal cost and you're asked to work backwards to find cost. Okay, so we take the integral, the 0.3 stays in front. This will be x3 over 3. Plus the 2 stays in front, x2 over 2. Don't forget your plus c, sorry, your plus c. Then 0.3 divided by 3 is 0.1 x cubed plus x squared plus c. And is that your marginal cost or cost? That is your cost. Now, we have a little bit of a problem. So you were hired by a company to do some math. And your first assignment was to go from their marginal cost, how their cost is changing, and figure out cost. And you go up to your boss and says, I did it. And your boss is like, great, what's the answer? Easy. To find your cost, you take 0.1 x is how many units, cubed, plus x squared, plus something. And what is your boss going to tell you? You're fired. What do you mean plus something? You got to tell me what the something is. Is it plus $1? Is it plus $1,000? Is it plus $10,000? Is it minus 5,000? You didn't give me a complete function because of the plus C. So you have to be given something in the problem. And you're actually given that the cost of 0 units is $3,000. And you're like, where did it say that? Fixed cost, $3,000. Fixed cost means when you have 0 units, your cost is still $3,000. Not marginal cost, cost. So they actually gave you X and they gave you cost. They have to give you some information because now I need to figure out what that plus something, the plus C is. So you know when the cost is 3,000, the number of units is 0. And you can find that something is going to be what? C equals 3,000. So you have to be given, you have to be given some information about cost so we can solve for C. Now that I found what C is 0.1 x cubed plus x squared plus 3,000. You can now tell your boss, here is your complete cost function. Now you can answer the last question, how much will it cost me to have 30 units? So if you plug in 30 into your cost function, which you had to figure out, you can figure this out. And I'm going to save a little time. I've already typed in the calculator for you. You will get $6,600. So you can now tell your boss, you started with marginal cost, you found your complete cost function, and you can now say at 30 units, the total, not marginal, the total cost is $6,600. So this answers the why do we do integrals. If you start with the derivative, you need to work backwards, marginal cost to cost, marginal revenue to revenue, marginal profit to profit, you take the integral. But every time you take an integral, there's a plus C. So you're going to have to be given some information to figure out that C. Then when you have the cost, you can plug in any number you want. Okay. So our last word problem, then we're done for today. Example 6, advertising. A satellite radio station launched an aggressive advertising campaign 16 days ago to increase the number of daily listeners. The station currently has 27,000 daily listeners, and management expects the daily listeners to grow at the rate of change, derivative of S prime T 60 T to the 1/2 listeners per day. So you are given not total listeners, you are given a rate of change. You are given listeners per day, where T is the number of days since the campaign began. How much longer should the campaign last if the station wants the number of listeners to grow to 41,000? So let's boil this down a little bit. T is time in days. Technically, it's since the campaign started. S of T is number of listeners. That's the goal. And you are given 60 T to the 1/2, but that's the rate of change. I don't want the rate of change. I don't want the listeners per day. I want listeners. So what am I going to have to do to that? Take the integral with respect to T this time. Why am I doing T? Because the variable is T. And believe it or not, in there is a given. The given that they gave you is that after 16 days of campaigning, how many listeners do they have now? 27,000. That given, we will need, why? When we take the integral, we're going to have a plus C. And when I have the plus C, I need to figure out what the plus C is. That given is going to help me figure out plus C. So your job is to figure out total number of listeners function and see if you can figure out how much longer until you get 41,000. That's the goal of this campaign, is to get 41,000 listeners. 41,000 listeners. So again, the idea is we have a rate of change and we're working backwards to find total. So the 60 stays in front, add 1, divide by it. I'm going to call it 1.5 divided by 1.5 plus C. So this is going to tell me total number of listeners, And then if you do 60 divided by 1.5, 60 divided by 1.5 or 3 over 2, just be careful how you type it in, you will get 40. So our answer is 40T to the 1.5 plus C. Unfortunately, we don't know what the C is, so we don't have a complete function. That's why we use the given. T is 16 when the number of listeners is 27,000. So I put 27,000 equals 40 times 16 raised to the 1.5 plus C. That's 27,000 equals, if you type that in the calculator, 40 times 16 raised to the 1.5. That gives you 2560 C, and then minus 2560 minus 2560, and you get C equals, if you plug that in, 24,440. So after all that work, you now have the total number of listeners is 40t to the 1.5 plus 24,440. Now, once you get to that point, be careful, little mistakes, all that wonderful stuff. We still didn't answer the question, but you can now tell me, based on how many days since the campaign started, how many listeners will we have? Well, they want to know, and the goal is to get to 41,000. So does the 41,000 go in for T or for S? 41,000 goes in for S. But then remember, algebra, algebra, algebra. So if you don't know how to do your algebra, you're not able to find T. So I'm just going to give you a couple minutes, little struggle there to see if you can figure out what T is. And I'll give you a little hint. What I'm going to do is, instead of using 1.5, which is totally fine, but instead of using 1.5, I'm going to use a little trick where instead of using 1.5, I'm going to use 3/2. That 3/2 is going to make it a little bit easier to do the algebra, believe it or not. So the hope is we started out by doing, okay, minus 24,400, minus 24,440. You're going to get 16,560 equals 40t to the 3/2. And then you're like, well, I'm going to divide by 40, divide by 40. And then you get t 3/2 equals 414. And this is maybe where we get stuck. Now, there are several ways. You can use log, ln. You can use those properties. If you remember, you can ln both sides, then the exponent goes to the front. That's one way to do it. But for me, the easiest way to do it, because it's a fraction, what would happen if I raised the left side to 2/3? What do you do to these two numbers? You multiply them. Or 2/2 is 1, 3/3 is 1, 6/6. You get 1. You get t. And if I raise this side to 3/2, what do I have to do to the other side? Raise it to 3/2, and that's it. Right? Again, you can use log. That's another way to do it. But if you do 14 raised to the 2/3, you will find that you get the answer of 55.55. 55.55, which we'll just call that 56 days. And if you want to really be technical, that's how many days total, how many days have already happened. So 56 minus 16, you got 40 more days to go. But again, algebra, algebra, algebra. Okay, and that ends the first section of chapter 5 in our